Next up, we have Johan Stenstam, who is going to be talking about multi-provider DNS, why it is important, where it is now, and how to make it simpler and safer. So welcome, Johan.
Thank you, Merike. So, some of you know that I've been working with what we originally called multi-signer DNS for quite some time now. We've done it in several starts and also several stops. And we have sort of struggled with and tried to find the right solution to this problem. We had what I consider a breakthrough in thinking about a year and a half ago, when we realized that this is not so much about multi-signer as in multi-provider. And that's sort of the starting point for this presentation, that we shouldn't focus on the signing part as, oh, that's very, very difficult and it has a very sort of limited audience, but we should rather focus on the multi-provider part, because it has a much, much wider audience. It's more relevant to many more zones, more important zones and all that stuff, but it also sort of frames where the problems really lie. So that's what I will talk about. And this is obviously something that we do at the Swedish registry together with parties in several other countries. And I have my colleagues who are, well, Leon is on paternal leave and Eric is home with kids, so it's just me this time. So if we go back to the problem statement here, well, multi-provider, again, focusing on multi-provider rather than multi-signer, that's already best current practice. There's a very, very, very large number of zones on the public internet that have multiple providers for very good reasons. And if there are multiple providers, somehow they need to synchronize stuff. In the TLD space, I mean, I work for the Swedish registry, and we obviously have multiple anycast providers like almost every TLD does. What do we do for synchronization? Well, we talk to each individual operator and say, okay, so you're serving our zone on what IP address? And then we manage the synchronization in our zone ourselves, because that's what the TLD does, and it's sort of manual and it's not automatic, and it works very well, but it's also a labor-intensive process. That simply doesn't scale to hundreds of thousands of zones or possibly even more. When you go below the TLD space and you start looking at enterprises, you need to find an automated, scalable solution that doesn't involve manual labor. So, and that's just for the NS records. As soon as you start doing DNS-SEC in multiple places and you get into the multi-signer space, then it gets really, really complicated. So, my point here, the only important takeaway from this, my rambling, is that this is not about multi-signing. This is about synchronization across organizational boundaries. In this case, it's about synchronization of DNS data that is sourced from multiple places. And we need to find a model for how that synchronization should take place. And that's really the core of the problem. Once we figure out how the synchronization should take place, it doesn't really matter whether we synchronize DNS key records or NS records or CDS records or whatever. It's the synchronization which is the core, not the signing. And all of these appear in the signed case, and some of them appear also in the unsigned case. If we solve the synchronization problem, and I think we are more or less there where we have solved it, suddenly multi-sign is for free. If we can do synchronization of arbitrary DNS data across multiple providers, again, it doesn't matter whether it's DNS keys we're synchronizing or NS records we're synchronizing. So suddenly multi-signer steps away from being a hard special case to instead being just one of the things we synchronize. And I see people falling asleep already, so I know I'm just after lunch, and the only thing that is holding me up and not falling asleep is A, I took a coffee, and B, I'm standing up. So I do sympathize with your problems here. So why is this difficult then? Well, we have a multiple sort of conflating different problems here. We have a trust and policy problem. How do you, as a provider, know who the other providers are? How do you know how to communicate with them securely? How do you know how to trust them? Again, looking at the TLD space, what we do is that we have this provider and we talk to him, and we have that provider and we talk to them, and we get the data from each and we integrate it here. So that's obviously a model that works, but it's also labor intensive. If I was an enterprise and I just said, I want to buy a DNS service from these two providers, DNS is not my core focus, you guys are the professionals, I just want you to sort this stuff out. Then these providers need a mechanism to locate each other, discover each other's, well, identity, and establish secure communication for synchronization. Once you have that identification and they know who the other party is, you also need to know whether the stuff you sent is actually published in the zone that the other guy is publishing. So you really need confirmed delivery. Without confirmed delivery, it's a sort of fire and forget and just hoping for the best, and that's probably not the model we want. And the third problem is, of course, that there is no standard for this. When I speak to people, and I speak to major providers, and I ask, how do you do this today? And they say, yeah, we go to the OARC contact list. And to me, that sounds like sort of a recipe for disaster at some point in the future. Because when you really need the other guy at the other end, he will have left that organization when it's urgent, when something has broken. So we really need to have some sort of infrastructure here that is automatic and works all the time, even if people change jobs and change email addresses. I mostly said that. So how do we actually propose that this works? Well, the major change from what is being done today is that we want to bring it out from sort of closed agreements between a zone owner and the provider to a transparent model where the zone owner publishes what he wants and what roles he assigns to different parties. And the way he publishes this is by publishing it in the DNS. That has multiple advantages. One advantage is that every provider, as in the subcontractors for the zone owner, they see the same information. There's nothing hidden here. There's nothing which is something I ask this provider to do and I require something else from that provider, and those two things happen to be incompatible. Today we can have a problem there. I'm not saying it's a common problem, I'm saying it's a possible problem. If I tell this provider that you should sign the zone and then you should send the signed zone over to this other provider and they should pick it up and they should serve it, and I tell the other provider something else, it will break because the instructions I gave to the two providers will not be internally consistent. If we make this public and everyone looks at the same information, we will see the same thing, and inconsistency becomes impossible. So we want to make this transparent and public. Okay, that's good. What are the consequences? Well, we do have the zone, and we send the zone through a zone transfer typically to both parties or to the multiple parties here. And they pick it up. They typically possibly sign it, not necessarily, but they could sign it, and then they could publish it, and obviously they need to exchange some information. So in the architecture that we are working with right now, we have something we call the agent. The agent receives the zone through a zone transfer from, let's call it the distribution master, is marked as signer here, but it's essentially the signed zone that we intend to publish is also sent to this agent. And the agent does this analysis of the information in the zone about who am I, who are the other providers, what is my role, what is the role of the other providers, and then I know what I need to figure out about the other providers and how to get in contact with them. And I do some synchronization, I talk to them, and I get some information, and once I have the information, for instance, I have their NS records that they want to add to the zone, obviously I need to somehow get this into the zone. And that's the blue thing up there, where it says that the agent sends stuff back to something we call the combiner. Why do we call it the combiner? Because it combines the information from the zone owner with the small but important additions that result from the synchronization across the providers. Typically, additions to the NS-OARC set, possibly glue, DNS keys. It's just a couple of RR sets, but they happen to be somewhat important to make this work reliably. So there are actually 4 roles here in this model. There's the zone owner as before, there's the agent that does the synchronization with other agents, there is the signer which signs and publishes the zone, and there is this combiner, and the combiner is sort of a glorified proxy. It sits between the zone owner and the signer, and on request it's able to make, let's call them very well-scoped changes to the customer zone. It's allowed to change the NS-OARC set if needed. It cannot change the arbitrary data. It's just a couple of RR sets in the Apex that it can modify on request. Okay, so what about this transparency that I talk about? We play with 2 experimental new record types. It's called hsync and hsync param. The hsync is only an identifier. It's something that the customer publishes in his zone, and he essentially says that I have this provider. I call him alpha. He is identified by the domain name, in this case agent.alpha.example, and he receives the zone from me, or rather the dot means he receives the zone through a manual setup process. We have another provider here called echo. He's identified by the domain name agent.echo.example. He should receive the zone from alpha, etc. So we publish the information here about who are the providers and how are they connected. We haven't said anything yet about what roles they should fulfill. That comes in the hsync param record. So in the hsync param record, which is essentially an SVCB with new SVCB params, we list who are the servers of the zone. They are the guys who serve the zone on various IP addresses, and by that definition, they could be able to contribute to the NS-OARC set. Who are the signers of this zone? That could be 0, 1, or more than 1 entities, but they have to be listed in the hsync records. And then we have a number of other key value pairs that we can have in the hsync param record. I'm just listing one here, NS management agent, which means that the agents, the providers, are in charge of the NS record set synchronization and management. The alternative is to have the NS management equals owner. That means that hands off, you're not allowed to make any changes to the NS-OARC set. This is under the control of the zone owner himself. He manages the zone and distributes it the traditional way, like we do as a Swedish registry, for instance. We talk to our providers and we integrate and change the zone rather than have them talk to each other. So these 2 things, the hsync RR set is only an identifier, and the hsync param says who is responsible for what function in this system is what makes this work. Once I get the zone from the customer, I will look for the hsync RR set. If I find myself in the hsync RR set, then I will say this is a zone that concerns me. I obviously have a responsibility here. And then I will look up the other HSync set, and I will discover those agents, and I will establish communication with them. So once you do that on incoming zones, and you look for the HSync set, you can establish secure communication with the other guys. Where should, I'm not sure validation is the right answer, the right word here. I wanted to keep the point where decisions about changes to the customer zone are made as small and simple and tightly scoped as possible. I didn't want to integrate that into the signer because that's a complicated piece of software. I didn't want to integrate that into the agent because that's a fairly complicated piece of software also. It does all sorts of synchronization with remote agents, and they send messages back and forth, etc. So the combiner is meant to be a very simple piece of software. It's just a DNS zone transfer proxy with a tightly scoped ability to change a couple of RR sets, together with a policy what it is allowed to change or not. So that's what the combiner does. And I see that I need to speed up a little bit here. I spoke about confirmed delivery, which is obviously needed for this. And I need to speak about self-healing because this is also something that makes this more robust. If a change or a synchronization message is sent more than once, it will not change anything. You can restart whenever you want. You can stop and start. You can send messages over and over, and it only reinforces, or rather just establishes, the same truth. It's possible, especially after a restart, to say, I'm restarting, I need all your information. And you can trigger all the remote agents to send you whatever they have. And that's the way we recover after restarts. And this sort of brings me to what I think is the most important slide, and that is the synchronization. Having worked with this for quite some time, there is this problem that it's possible to sit around for years talking about stuff and never sort of converging. And you never get to the really, really hard issues until you actually have a system to play with and you realize that, oh, this is actually hard. And the hard issues in an architecture like this is deciding who should be allowed to provide what. Where should the control be? Should it be in the sender end or in the receiver end? How should we arrange for persistence across restarts, etc.? How should we arrange for guarantees against spoofed or wrong data to enter the system? How should we sort out who is responsible for parent synchronization, for instance? Etc., etc. We have changes also to the state machine for DNS and key rollovers. There are a bunch of specific issues when it comes to synchronization of DNS data across multiple parties. And I'm not saying that this is trivial. I'm saying once you start focusing on one of these pieces at a time, the solutions or the correct answers are there, but it's a discussion that needs to be held, and we couldn't hold the discussion until we had something to play with, so we realized what didn't work. And that's exactly where we are. We do have a prototype. It works, mostly, and we've sort of sorted out all these hard corners, and I couldn't even phrase those corners into words until we had the prototype so we could discuss it. So the short answer of where we are is that this actually works. It's open source, it's available on the internet, you can clone it from GitHub, and it works. It does all the things that I've spoken about. It doesn't do a couple of things that I haven't spoken about. Like, for instance, we're not quite done with the parent synchronization part. We have sorted out who should be responsible, but we haven't quite sorted out the implementation of generalized notifications for CDS and CSync. We're close, but not quite done. We have done automated key rollovers for a single signer, but not for multiple signers. We have communication infrastructure fully working based on DNS messages back and forth. We do not yet have the REST API, which we also intend to provide. So a lot of stuff is done. A couple of crucial things are being done, but not quite done. But it's still sort of past the point of we already know that this will work. There are no hard research questions remaining. It's only engineering questions that remain. And that sort of brings this to a close. It's harder than I thought initially. I'm convinced that we have found the right model. I care less about multi-signer today than I did a year ago. I care more about multi-provider than I did a year ago, because multi-provider and finding the model for synchronization of DNS data across providers is a very, very interesting problem, and I think we've solved it. And I believe that the HSync RR set and the transparency, making sure that everyone sees the same information, is really the key to making this work. So that's where we are. Any questions?
Yep, please come up to the microphone and state your name and affiliation.
Hi, there's a question from Joe Abley.
Oh, now I'm scared.
I'm interested to hear why authorization and authentication through HTTP APIs is not the answer here, as it's for most other examples of cross-service authorization in modern world. Stuffing all that provisioning metadata and process flow into the DNS feels clever, and obviously I like it, but I don't know why it is necessary or sensible.
Short answer, it's not necessary. But the just slightly longer answer, I mean, what Joe is asking about here is that we today do all this synchronization on port 53. So we send messages back and forth, which are DNS. If I want to set up 3 different name servers, doesn't matter whether they are run by me or by 3 different people, and these name servers are standard open source name servers that we all know and love. Those things typically only talk on port 53. And in many cases, they are in infrastructure that only lets traffic through on port 53. And if I start allocating different ports for TLS communication, for instance, suddenly I get new dependencies. I get CA dependencies, and we may have different CAs on top of our certificates, etc. And I get new ports, and I get new dependencies. So I'm all in favor of having a TLS REST API-based synchronization transport. And I will build it. I just started out with DNS because that's easier to integrate into the open source name servers.
Great, thank you. Jens?
Jens Hofrichter from P-Square. Are you planning on having those HSync RR sets publicly on the internet, or are they being stripped out before publishing to the edge and just...
They are today public on the internet.
I think that might have been quite big security implications for security departments in the enterprises, because that gives out information about your DNS setup, your contracting setup, and that's something I just wanted to make aware that that is something where I would see corporate security really being
that has been discussed. I cannot say that I have an answer to this, because this is obviously in the eye of the beholder, and the beholder in this case is the zone owner. And if the zone owner considers this a problem, then it's a problem. So I completely agree with that. It really depends on what the situation is. I mean, if you are a zone owner and you consider, I don't want to tell the world exactly who my providers are, and obviously you have some sort of zone transfer set up to your different providers, and you put the HSync and the HSync param RR set in there, and you tell them you should sign and you should zone, etc. If the zone is unsigned, there's nothing precluding stripping out the HSync stuff afterwards. However, in a different model where you sign the zone yourself and you only have providers, again, like the SE zone, we sign the zone and we have a bunch of anycast providers. It would obviously be rather difficult for them to strip out the H-sync stuff afterwards. So it really depends on the model. And the more I talk to people, it seems to be less and less of an issue. But I'm not discounting that some people may consider it an issue.
Okay. Thank you very much.
Thank you. More questions?
Okay, if there's no more questions, thank you very
Thank you.
much, Johan.
Thank you.